Alright, welcome to the video on drawing single bonds. So today or tomorrow in class we're going to be drawing molecules, and so let's start with drawing molecules that have single bonds. Definition of a single bond: two atoms share two electrons. Remember, when you have an ionic compound, you transfer electrons from the cation to the anion. And when you have a covalent compound, then the electron gets shared between the two atoms. So for example, let's try iodine. And you're thinking, iodine, that's not a molecule. How can it share atoms? It's just an element. No, it's not. Remember your diatomics. Iodine, I2. So that means I have two iodines. So I have this iodine here. And we're going to look on our periodic table and figure out how many valence electrons it has. Remember, drawing Lewis dot diagrams from unit 6, last unit. So iodine has 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. And then we're going to have our second iodine. And it also has 1, 2, 3, 4, 5, 6, 7 valence electrons. Okay, now remember, everybody wants to get 8 valence electrons. So we wouldn't want the blue iodine to give its electron to the red iodine, because then the red iodine would have 8, but the blue iodine would only have 6, and that's even worse than where it started. So instead they're going to share these two electrons. So these two electrons are going to pass between the blue iodine and the red iodine, like this. And when the electrons are over here, the blue iodine is happy. And when the electrons are over here, then the red iodine is happy. So they're only happy half the time, but that's better than being miserable all the time, right? The way that we represent these two electrons being shared is we use a single bond. And single bonds are done as a line. So those two electrons become this line here between the two iodines. And then we have the others that are not being shared as dots, like so. So this is a bond, specifically a single bond, because only 2 electrons are being shared. And then these are called lone pairs. Lone because they're not being shared, and pairs because we write the electrons in pairs. And then we know that we've got the right drawing of our molecule if everybody's happy. So this iodine has 2, 4, 6, 8 electrons. That single bond counts for 2 electrons. So it's happy. And this iodine has 2, 4, 6, 8 electrons, so it's happy. Both of those iodines now get to count these electrons, and so they both get to satisfy the octet. And that's what you call a single bond. So, how are we going to draw these? Now, it's not going to be as simple as drawing this iodine. Okay, that was just a very simple one just to start us off. As the molecules get more complicated, you're going to need to follow these steps. So write them down. The first thing you got to do is figure out what element is going to go in the middle. Now, in this case, we have iodine. There was no middle. There was one end and the other end, and that's it. But if we have more than 2 elements, more than 2 atoms, then somebody has to be in the middle. We've got to figure out who that's going to be. First of all, it's never hydrogen. So if you have a very complex molecule, let's say we've got, something like glucose, C6H12O6, and we have like 24 different atoms, who's going to go in the middle? It's not going to be hydrogen, ever. Next, it's the oddball in the formula. So let's say that we have a formula like CO2. We have 2 oxygens but only 1 carbon. That makes carbon the oddball. Therefore, carbon's going to go in the middle. And lastly, if they're both the same, let's say we have, let's say we have H2O2, then there's 2, okay, that was a terrible example because we're never going to put hydrogen in the middle. Let's say that we have HCN. Okay, so they're all oddballs. We know that hydrogen is not going to go in the middle, but is it going to be carbon or is it going to be nitrogen? We're going to look on our periodic table. The element with the fewest valence electrons is going to be the one that goes in the middle. So in this case, it would be carbon because it has 4 valence electrons. Nitrogen has 5 valence electrons, so it's going to go on the end. All right, so our first step is to figure out who's going to go in the middle. It's never going to be hydrogen. It's always going to be our oddball. and it will, if all else fails, it's the one with the fewest valence electrons. But again, never hydrogen. It's always going to have fewest valence electrons. Incidentally, if you're thinking to yourself, wait a minute, hydrogen is a metal, and therefore it belongs in the ionic compounds. Why are we talking about these in covalent compounds? Hydrogen is a weird little molecule, sorry, not molecule, but a weird little atom. It actually can count as either a metal or a non-metal, depending on what's happening to it. In this case, we're going to be counting them as non-metals. So if you ever have hydrogen in with a bunch of other non-metals, hydrogen is going to consider it as a non-metal, and therefore we're talking about covalent. All right. So the first thing we got to do is figure out which element goes in the middle. Let's try our example over here, ammonia. Ammonia is very close to your polyatomic that you memorized, which is ammonium. Ammonium is NH4 with a little plus sign. Ammonia is NH3. So our first step is to figure out, of these 4 atoms, which one's going to go in the middle? Well, it's never going to be hydrogen, so therefore it's going to have to be the nitrogen. Our second step is to then arrange the letters on our paper. So if the if the nitrogen is going to go in the middle, then the hydrogens are all going to have to be around the nitrogen. It's not always going to be in a straight line like it was with the iodine. So we're going to put one, draw that very well. We're going to put one hydrogen over here, one hydrogen over here, and one hydrogen over here. It doesn't really matter which 3 sides of nitrogen get hydrogen, as long as they're all able to touch the nitrogen. That's why it's in the middle. Next, we're going to do a little math. And by a little math, I mean a little math. Okay, just adding and subtracting small whole numbers. So we're going to figure out how many valence electrons each of these guys have. We're going to add them up. We're going to need to use our periodic table for that. So we find that nitrogen is in family 5A, and therefore it has 5 valence electrons. So nitrogen has 5 valence electrons. This is our valence electron column. And there's only 1 nitrogen in our formula, so that means we have a total of 5 electrons from our nitrogen. Hydrogen is in family 1A, so therefore it has 1 valence electron, but there are 3 hydrogens, so there is a total of 3 hydrogens coming from our nitrogen, a total of 3 electrons coming from our hydrogen. So now we're going to add this up. 5 plus 3, 8. Hopefully you're still with me as far as the math is concerned. That was step 3. Step 4, bond the outer atoms to the central atom. It's not a molecule until you're bonded. So we got to take our outer atoms and stick them back onto our central atom. And that's why it's in the middle. 5, we're going to subtract 2 electrons for each bond. So here we go. Here's our bonds. We're going to subtract 2 electrons, so now minus 2, and we made 3 bonds. So -2 times 3, -6. So now we're left with 2 electrons available. Think of this as like our electron pool. We have all these electrons, and we're going to put them in places. And so we just put 6 of our electrons in these 3 bonds. Next, count how many electrons each atom still needs and compare it to how many electrons you still have. Now here's where it gets interesting. I told you before that hydrogen is a weird little atom. Hydrogen is the only one that is happy with 2 electrons. It does not want an octet. It does not want 8 electrons. It only wants 2. So this hydrogen wants 2 electrons. It has 2 electrons. So it needs no more electrons. And this hydrogen needs no more electrons. And this hydrogen needs no more electrons. The nitrogen does want 8 electrons. It has 2, 4, 6 electrons. So therefore it still needs 2 electrons. So of our molecule, we still need 2 electrons. We have 2 electrons. So this is our need. This is our have. So we're going to compare our need to our have. A, if the need equals the have, then we're just going to put lone pairs on the atoms. So our need equals our have. So we're just going to take our 2 electrons left here in our pool and stick them on our molecule, and we're done. If, on the other hand, we get to a situation where our need is greater than our have, if we need more electrons on our picture than we have available in our count, then we're going to have to add another bond. That's when we get to multiple bonds, which is the next video. And once we add the other bond, we're going to have to recount. Thirdly, you have a possibility of your need being less than your have. We don't need as many electrons on our picture as we have available in our pool. If that happens, you have something called an exception to an octet, and we're going to do that not this coming class, but class after that. We're going to have a video on that. And in that case, you put the extra electrons on the central atom. So this is this video right here. If need equals have, you have single bonds, and that's it, you're done. This is when you have multiple bonds, and this is when you have an exception. We'll talk about that much later. So now you have all the tools you need in order to draw any molecule that has only single bonds. Thank you.